Hello, welcome to this new video on Java series. So we have been discussing in Java collections framework for Java in the last few videos. Today I'm going to discuss about this blocking queue. In the previous video I discussed about the queue interface in Java collection, and today I'm going to discuss about this blocking queue. So before I go there to discuss this blocking queue, one of the things important thing to note is that in Java there are two types of queues, and you can just say they're like one of them is unbounded and other is bounded queue. So what we do in bounded, basically we define the capacity, of the queue is bounded, how many elements the queue can have. So when we create the queue queue class in the beginning, we specify the capacity or in the constructor of that queue. So that's important. In the unbounded, we don't specify the size of the queue or how big the queue is going to be. So it's just has kind of like unlimited memory. The only thing is, if you keep adding elements to queue and it's unbounded, eventually your JVM might run out of memory actually. So that's the only drawback on this one. Out of memory could happen if you keep adding elements. But on the other hand, you have a bounded queue actually, and here you specify capacity, and let's say you said, yeah, this queue can contain only 100 elements, and now you define the size of this queue. Actually it's 100 elements. So the problem with this queue is now you have to start managing it, because now you have to keep track, or how many elements within the queue. Can you add more elements? Let's say the queue is already full. Should you be able to add more elements to it? Or if the queue is empty, can you get or remove elements out of the queue actually? So in order to handle those kind of scenarios actually, because a bounded queue, it has a capacity, and let's say it's already full and you try to put a new element into this one, a new item into this queue, what happens? So that's where this blocking queue interface comes into picture, because this blocking queue interface has some additional methods on top of the methods which are already provided by the queue interface. So you should know this, blocking queue, it extends from the queue interface. So basically blocking queue contains all the methods which are in the queue, plus it contains additional methods, and that's the additional methods I'm going to talk about in this particular video. What are those methods? And those are the methods which can deal with this blocking queue. So what this blocking really means? So blocking means this blocking queue has methods, to add an element. It has methods like you can also do add, remove, but these methods are coming from this queue interface, so therefore like unbounded kind of queue. If you add an element to already a full queue, or this will just throw some kind of error actually. So I'm not going to discuss these methods. So what I'm going to do is I'm going to look at those specific methods which are provided by this blocking queue interface, which are very handy for dealing with this bounded queues actually. So, and I'm talking about those methods. One is called put and other is called take. So instead of using add and remove, we are going to use, so this blocking interface provides this method put. So let's say you try to put an element into a queue which is full, so this will wait until the space is available. So it will wait to insert if the queue is full. They have this method take. It will also wait to remove if the queue is empty. So these methods are very handy and they take care of everything for you. If the queue is full, it will just wait, and it will, when the space becomes available, it puts the element into the queue. But the thing is now, there's a little different concept of threads coming into picture, because now you have two different processes. One, you can say one thread which tries to put element into the queue, which is a put, but there's another thread which tries to take elements out of the queues, and there are two different threads which are trying to put elements or trying to take elements of the same queue. So the queue is shared, but there are two different threads running, which one of them is kind of putting the elements into the queue, and that thread we call is a producer, because producing the data to be put into the queue. The other thread is called a consumer, because it's taking the items out of the queue and consuming those, or taking them out actually. So let's quickly, I'm going to do it with the help of an example. So I have not discussed about the threads in Java, but I think we are going to touch in some of the future videos. But right now what I'm going to do is, I'm not going to the main method. I'm going to write this class. I call it a producer. So this will be the class which will keep, I'm going to, so runable interface. So yeah, so if you have to implement a thread, you have to implement this interface. So I think it's pretty straightforward, but I think we will go here. So let's see. So we have this class, so runable, and what I'm going to do is here, we are going to say blocking queue, and the elements of the queue are, let's say, strings. And we have to, so all of this are coming from now Java util.concurrent, because all of this blocking stuff is in this queue. So we just take it from there, and we're going to implement this method here quickly, but just wait a second, so we can just implement that method. So what we can do now is, so this is a producer. So what I'm going to do is, now I'm going to create a constructor, because this producer is going to take this queue, blocking queue string, and I'm going to assign to this .queue equal to queue. So I just did a little this constructor, so that we can pass this queue object into this producer. And this run method is the method which is going to really because this is a thread, so when you run this thread, this run method gets called actually. So what I'm going to do is, I'm going to let's say I'm going to put 10 elements into this queue quickly. So 0 I less than 10, I plus plus, and what I'm going to do here is, this is a, I'm going to say queue, and I told that we are going to do put, because that's a blocking method. And since it takes a string, so I'm just going to kind of put a dummy kind of empty string and concatenate it. And here I'm going to say, because we can just later on see this message here, say we can say what we produced actually. We produced here nothing but this I, which is really, it's going to put numbers from 1 to 9 into this queue. Okay, so the thing is, because when you put the stuff into the queue, it needs to, if the queue is full, it's going to okay, so I'm going to take this try block out of here and put it outside really. This catch, okay, okay, this one can go out of here. This also has to go here. So what I'm trying to do is, I'm just trying to make it little tidy. So let's see, so we can just format it quickly. Yeah, so we're just trying to, if you notice, this queue is nothing but we are trying to produce numbers from 0 to 9, and we are trying to put into this queue, but it said I need to wrap it around the try catch block, because it could throw exceptions. So that's why I interrupted exception. So that's what I did here. I'm going to copy this, because I'm going to write also a consumer which is going to be exactly like same. So I'm going to say copy, and I'm going to paste it here, I'm going to call it consumer. So consumer. The only thing I have to change here is so in the consumer you have to take the message out actually. So what I can do here is I don't have to do this. Well, I still have to do the this thing, but I think I can do this while. So I want to take the message out of this queue. So now this queue dot and I mentioned we have to use the take method. Let's see, we want to put that in some kind of variable. So let's say message equal to, we can pick the message and put it into variable here. So we can say message equal to so many. We can run this while the message equal. So I think what I need to put on the producer is I'm going to put some, so it puts like elements 1 to 10, and I want to put one more element here. So I want to say queue dot, well, you know what, I don't need that one. So it puts 10 elements, and I know the last element is 9, so I can do that. So queue dot take, and I can say well, so dot equals, so 9. So we keep it running until it's 9 until, yeah, so actually, you know, let's do up to 10, because what I can do is here I can put another element into the queue, and that's our, like, you know, terminator, you know, something we call it a last element of the queue, so that we know this, that when you hit this 10, you send up the queue, you know, because here it will put up to 9, then put last at that 10. So I just, instead of 9, yeah, 10. And what we can do here is, okay, so we got the message, and then I can just try to, so I took the element out. So we can do is print this element now. Consumed. What we consume here is message, because that's what message came out of this one. So consumed. So let me just put it on this one little side by side. This one here. Okay, let me break also this into side by side so that we can see all this together. Okay, here's the thing now. The main one method, you know, what you have to do is here. So we have the producer, we have the consumer. So what I want to do is, let's create this queue now here. So we said blocking queue string, and we call it just queue, and we have different implementations, but I'm going to use array blocking queue because we know this bounded queue, and I'm going to put it a size of 5. So just to prove you that, you know, what it does when you try to put an element but you don't have any space available in the queue. So we have this queue 5. So now, okay, so we have this queue of 5. So now I'm going to create producer. So let's say we have producer equal to new producer, and if you remember, the producer takes this queue, and remember this is the common queue which is for consumer and producer both up. So we pass the queue to this producer, and this is the queue we created it here, but we're going to pass it to producer, and we also going to pass it to consumer. So let's say consumer new consumer, we passing the queue here. So we pass the queue to both of them. So because the producer is a thread, it's a thread because it implements this runnable interface. Consumer is also a thread because it implements the runnable interface. So thread you can consider is another small or lightweight process within this Java. You know that we have the main method which runs and it's one of the thread, but within that you have another threads, and thread, when you start a thread, it keep run the run method, and it keeps running it until it has finished running this whole thing inside this method actually. So we have these two methods. So what I'm going to do is now I'm going to create thread t1 equal to new thread, and in the thread I'm going to pass this producer. Okay, and then I'm going to say t1 dot start because it's a thread. I can create another thread to t2 equal to new thread, and I called it, pass it consumer t2 dot start. Okay, so let's see. So what we did is we have a queue which is we have a queue which is of size 5 here. Then we have a producer which keeps adding elements to the queue. We have a consumer which keeps taking elements out of the queue. But our queue is only 5, but we are trying to put 10 numbers. So what will happen is when it gets full, let's say it put 5 elements, then it will wait for the consumer to at least get something out of that queue. And as soon as it gets out of the queue, it will start putting the next element into the queue. So let's see. Let's try to run it and see what happens. Then we can just tweak it a little bit more. Okay, so you can see that. Okay, so yeah, it did. I think it did everything. It produced 0, produced 1. It produced mean it put 0, it put 1, it put 2, it put 3, 4, 5. So if you see, it put only up to 5. Although my loop goes up to like less than 10, it should have put up to 6, 7, 8, 9, 10. But this doesn't have that capacity. It cannot. It has a capacity of 5 only. So it didn't really go that far. It waited for it to consume. So it's consumed here 0, 1, 2, 3, 4, 5. Then it starts producing. So let me just put a little what do you call this? I'm going to put a little wait here so that this thread sleeps for a little bit. So what I'm going to do is okay, so I put a little break here, but let's say for the consumers, I want to put a little bit more wait. This thread dot sleep, what it will do, it will make the thread to sleep for some time, and I want to really slow down this consumption. So let's see. Okay, so I think it produced 0 consumption. Okay, so this, if you see, it's produced 6, then it consumed 2 because produced 7, consumed 3, produced 8, consumed 4, produced 9, consumed 5. So you can see that it has like we can just say here like done producing, because once you reach here, it means you have done producing, nothing to produce more. And if you come here, it says done consuming because you're out of the end of this method. So let's run one more time. So consumed so if you see up to produce 6, then it waits for it to produce before it can. I think I need to increase it a little more so that I can just see. I think let me stop it. Okay, here you go. It's consumed, produced. So okay, so it produced 5. So then when it's consumed 1, then it produced 6, then it consumed 2. Now it produced 7. It didn't produce 8 immediately because it allowed it to consume 3 first, then consumed 4, then it produced the next one. So it's done producing and it consumed 5. But remember, I put a timer of 4 seconds here. So it's consumed 6, consumed 7, consumed 8, consumed 9, done consuming. So you see this how it works. So the key thing to remember about this blocking queue, these are very handy for certain kind of situations. So blocking queue is the same queue what you have done in previous, but it has additional methods which provides blocking access. Blocking access means if the queue is full and you try to put another element into the queue, it will wait. Same thing. If the queue is empty and you try to take an element of the queue, it will wait. So that's what it does actually. And I have used the concept of this threads here, so we'll probably go in one of the future chapters how to do the threads. But that's the use case for threads. Like thread is nothing but it's a small process which just starts. You can do this implements runnable, that's the interface, and you have to implement this method. So whatever is inside this method that can run in a thread, and it once it's done running everything, then it just exits or thread will terminate. And I hope you like this video. Please consider subscribing to the channel and like this video, and I hope you find this information helpful, and I will see you in the next video. Thank you. Bye.